Graphing linear equations in slope-intercept form. So slope-intercept form is just y equals mx plus b, where the y value and the x value are your variables, and this m right here that is attached to your x, it's your coefficient of x, that represents our slope, or our rise over run. Or if you're working on a word problem, sometimes you'll see the phrase rate of change. It's basically giving you your walking directions, your moving directions. What is your graph doing as you move across the coordinate plane? This b value is your y-intercept. That's just where your graph crosses the y-axis. So let's look at a couple of examples. This first one says y equals 1/3 x minus 2. So our b value is a constant. It is by itself, and we can see this minus 2 is our y-intercept. So we are going to go to our y-axis and plot a point at -2. That's our y-intercept. It's where we start. It's how we begin. B for begin, if that helps you. Now, our slope is 1/3. Now, because our slope is equal to 1/3, those are both positive values. The rise, or the y, goes up and down, and because the 1 is positive, that means we're going up. Now, the run, which moves left and right, is also positive, which means we're moving to the right. So start on your y-intercept. Let me use the highlighter. Start on your y-intercept and count up 1 unit and to the right 1, 2, 3. And then you'll plot your new point. Up 1 and to the right 3 and plot your new point. And you can do that again however many times you need to in order to get a picture that you're satisfied with. So we start at our green point here, go up 1 unit and to the right 1, 2, 3. And now we have 3 points. But let's say I want to have a 4th point. It's not necessary, but you know what? I just will like the way it looks better. Or maybe I want to make sure that I get part of my graph over here on this side of my y-axis. So I need you to recognize that a positive 1/3 is equivalent to a -1 divided by a -3, right? A negative divided by a negative gives us a positive. If this is the fraction that I use for my slope, that means I'm actually going down 1 unit and left 3 units. So starting from my y-intercept, this red point, I'm going to go down 1 and to the left 1, 2, 3. And now I have another point that's on the left side of my y-axis. Like I said, it's not necessary. It's just visually appealing in my opinion, which really doesn't mean anything, right? So connect your points. And make sure you put your arrows on the end to show that your line is continuing forever. It's going infinitely far to the left and to the right, up and down. Okay, our next example, y equals -2x plus 1. We can see that our y-intercept is +1, so I will place a point at +1 on my y-axis. And now our slope is just -2. Well, that's not a fraction. Just remember that anytime you have an integer value, you can divide by 1, and it's equivalent to itself. So what does this mean? That means our rise is -2. Our rise is our y, so we're going down 2, and we run back and forth left and right. If our run is positive, we're moving to the right. So start on your y-intercept and count down 2 units and to the right 1 unit. Down 2 units and to the right 1 unit. Of course, if you wanted to, our slope could also be written as +2 divided by -1. If your slope is negative, you just assign the negative value to either the numerator or the denominator. In this case, that means we would go up 2 units and left 1 unit. So starting from my y-intercept, I would go up 1, 2, and left 1. Up 1, 2, and left 1. And then just connect your points. Make sure you have your arrows drawn on either end. And again, you only need 2 points to graph a line. Now let's look at this next example, this last example. I just wanted to show you what it looks like if you have an equation that is not in slope-intercept form. You can, of course, rearrange it algebraically to make sure, or to change it into a format that you like. So I'm going to go ahead and draw my line and isolate my y variable, get my y variable by itself. So the first thing that I need to do is, there's my y variable, add 6 to both sides of my equation. All right, and because 3x and 6 are not like terms, we'll just write it as 3x plus 6 equals 2y. And our minus 6 plus 6, of course, cancel to 0. So I'm almost there, but I still have that 2 in front of my y variable, so I need to divide everything by 2. Divide everything by 2 so that my equation is still balanced. Okay, so 3 divided by 2 does not reduce, so I'm going to go ahead and leave it as 3 over 2, x. And then 6 divided by 2 is 3, so plus 3 equals 2 divided by 2 gives us 1, so 1y or just y. Now, because this is an equation, it doesn't matter if you flip-flop the left side and the right side. This equation right here is the same thing as saying y equals 3 over 2x plus 3. And here, of course, we can see that our y-intercept is this positive 3. So let's plot that, positive 1, 2, 3. And our slope is this 3 over 2, which means we're going up 3 and right 2. So I start here and I go, oh, I only have 2 steps. My coordinate plane, I don't have enough paper here. So I'm going to go ahead and say, okay, well, my slope of 3 over 2 is equivalent to negative 3 over negative 2, which means I would be going down and left. So starting from my y-intercept, I can move down 1, 2, 3 units and left 1, 2 units. Down 1, 2, 3, left 1, 2. Connect my points, draw my arrows, and that's it.